So picking up from where we left off, we're now going to look at optical fibres and see how they use total internal reflection to transmit information. So as I've just said, they use total internal reflection to direct the path of pulses of light, and so to carry information. I've done a drawing of an optical fibre below, and we're going to label that and see the various bits involved. So this bit in blue here, this is the core, and that's what the light actually travels through. And this bit in black here, that's the cladding, and we're going to discuss the purpose of that in a moment. And then as we can see here, we've got light rays in grey. Sorry, light rays. And then here, where the light rays hitting the boundary of the core cladding, so the core cladding boundary, we've got total internal reflection. So we see that the light rays totally internally reflect every time they hit the boundary, so long as the bend radius is big enough. Excuse me. That is to say that we haven't bent the fibre too much, is effectively how you should think of that. That's what bend radius big enough means. That just means that we haven't curved the fibre optic too much. If we do that, then that can affect whether we have total internal reflection or not. So the purpose of the cladding, well, the cladding has a low refractive index than the core, which has a uniform refractive index. So the core could be drawn glass, for instance, or something like that, and that has a constant refractive index. And then the cladding has a much lower refractive index, so that we have our effective total internal reflection. Remember, that doesn't work if we have a higher refractive index outside. So we need a low refractive index to make sure that the light ray speeds up and then can effectively totally internal reflect instead of refracting into the material. The other reason for having cladding is that without cladding, any contact between the optical fibres would just lead to rays crossing from one to the other. So for instance, if we had maybe another fibre here and they came into contact and we didn't have this cladding, well, the cores would just be in contact and the light could just travel through the glass into each other. We just have the same medium here with the same refractive index, and so there'd be no reason for the light rays not to just carry on through. And so this light ray could, for instance, travel into this one if we had a different core here, and that wouldn't be good. Or why wouldn't that be good?
Hey guys. To continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.